Hello everybody, welcome back to this summary series and we are going to continue with organic chemistry. Today's topic is having the highest weightage in organic chemistry, in entire organic chemistry, designed for your boards as well as for NEET and JEE examination. So aldehyde, ketones and carboxylic acids are the very important functional groups in organic chemistry. Using these functional groups, using these compounds, you can make a library of organic compounds in the laboratory. So let's start learning their method of preparations and then their chemical properties. Let's start with the first topic for today. I am your teacher, Dr. Lakshya Kadhuria, and here we go. Let's start. The very first thing we will be discussing is some method of preparation and the properties of aldehyde in particular. After that, we'll discuss some methods of preparation. MOP means methods of preparation and some properties of ketones. Finally, carboxylic acids. And we will be discussing some reactions. Some means the reactions of acid chlorides are anyways limited. Whatever reactions are listed in NCERT, I have brought 100% all of those. Plus, in addition to that, there are some more reactions. So you need not worry if NCERT is covered or not. 100% NCERT is covered. This whole thing is having 100% of NCERT plus some addition of new reactions, some more reactions which will be useful. This session will be useful for your NEET examination as well as for JEE mains examination. And then we'll discuss esters, amides, and finally acid anhydrides. This session is going to be very interesting. I want you to have your pen paper ready and keep noting down the things which you are hearing for the first time. Okay, let's begin with the very first topic, that's preparation of aldehydes. What is an aldehyde? Aldehyde is a carbonyl containing compound. On one side of the carbon, the third valency of the carbon is satisfied by hydrogen and the other one is satisfied by hydrogen or by a carbon based compounds. So it has to be, for example, CH3, C double bond OH, this becomes acetaldehyde. Or you can start with HC double bond OH, that is your formaldehyde, and that's the simplest aldehyde that we know. Simplest aldehyde it is. Okay? Then, how do we actually make these compounds in the laboratory? That understanding we need to develop. So aldehydes are of this framework as I mentioned. So in the middle I have brought to you one particular molecule, that's CH3 C double bond OH. Starting from compound number 1, let's learn how we make aldehyde, that's acetaldehyde. Then from reaction number 2, then from reaction number 3, then from 4 and so on. So I have numbered the very first one, that's acetylene. What do we do to acetylene to obtain acetaldehyde? So what are we doing basically? We are changing this functional group from a carbon-carbon triple bond to carbon oxygen. So we need source of oxygen, isn't it? This is not having any oxygen. So let's use dilute H2SO4. And dilute H2SO4 meaning it has H plus as well as water present with it. So these two things are present together. So let's write down its mechanism. How is this compound formed? So we will be starting from acetylene, that HC triple bond CH. Let's react it with H plus in presence of water. So one of this pi bond will initially attack on this H plus to obtain HC double bond CH. And another H has come. What's the source of this hydrogen? This is H plus. This carbon should be gaining a positive charge which will be immediately attacked by water. So that's H2O. As a result of this, you will develop OH here. Correct? Is the systematic representation of this reaction clear, everybody? We started from acetylene, we reacted with acid, and upon the generation of carbocation, then water attacks. This oxygen lone pairs are attacking. And now they form bond. There are two hydrogen present with oxygen positively charged. This oxygen will immediately try to be neutralizing and you will obtain HCOH double bond carbon CH2. There is a hydrogen also present here, right? Now this molecule contains two function group. This is known as ene functional group and that's known as ol functional group. So together it will be known as enol. What is it, guys? Enol. Enol it is. We know a process called tautomerism. Tautomerism. Organic chemistry is a fundamental subject, guys. Unless you understand its fundamental, organic chemistry can become a mystery. But if you understand all those basics, there is no other subject which are of that logical sense. I'm in just love with organic chemistry. You will also start loving organic chemistry once you understand the concepts. So I have enol, then this is CH2 molecule. In tautomerism process, generally one of the hydrogen hop from one place to the another, jump from one place to the another. This carbon double bond breaks. What's the driving force for this tautomerism? The generation of carbon double bond oxygen, which is of much more strength than carbon-carbon double bond. Carbon oxygen is of much more strength than carbon double bond. This is stronger bond. This is of much more strength, much more stability. Once this hydrogen is jumping, this double bond jumps to this carbon, it will gain a negative charge. This negative charge will be neutralized by picking up this hydrogen. Hydrogen is now bearing a positive charge. There will be eventually new bonds formation and you can see that there is carbonyl obtained. So final product obtained would be acetaldehyde. This is your CH3 with CHO group. Is this mechanism clear, everybody? Starting from acetylene, attacking it by water, you can finally obtain enol. Enol under tautomerism process will obtain acetaldehyde. Clear? Let's take up the second reaction. What was the second reaction, everybody? You have CH3CH with two halogens attached and it is reacted with aqueous KOH. How many moles? 2 moles. So let's react. You have carbon with one hydrogen and one CH3. There are two halogens present. Once you have to attack it with aqueous KOH, we know aqueous KOH is responsible for SN2 reaction. This OH minus attacks on this carbon, this halogen leaves. Once this halogen has left, there is one OH present. There is one halogen present. Still, there is one more halogen present. I have utilized 1 mole of aqueous KOH. Let's bring another mole of aqueous KOH. There is K plus and OH minus. Since it is an ionic compound, it will attack on this carbon. Again, pure SN2 attack. As a result of which, you will be having 2 OH groups attached to the same carbon atom. But that situation is not very stable. Immediately, there will be loss of water. Loss of water, H2O will be lost because carbon cannot tolerate electronegative elements attached to it directly. For example, 2 oxygen atom, 1 carbon, 1 nitrogen and oxygen atom, 2 chlorine. So these kind of situation will be very difficult for carbon to handle. Immediate loss of water will generate acetaldehyde. Understood, everybody? That was your second reaction. Let's see the third reaction now. Third reaction is this we have studied already in alcohol phenol ether chapter. This is a signature reaction of an alcohol. If you want to oxidize it to an aldehyde, you must use a mild oxidizing agent. For example, PCC or PDC. PCC is pyridinium chlorochromate and PDC is pyridinium dichlorochromate. Both of them will restrict the oxidation to just aldehyde. All right. There is the third reaction. There is a fourth reaction written on this side, on this panel, that is starting from acyl chloride. This is known as acyl chloride. Once you react it with palladium barium sulfate, that is one of the catalysts used here. Palladium is used as a catalyst, but barium sulfate is going to poison some of the catalytic sites. Therefore, it reduces the capacity, reduces the ability of palladium as a catalyst to 100% reduce this compound. So what it does, it will just replace this chlorine and bring in one hydrogen at its place. It will just substitute that. But if you do not use barium sulfate, what is going to happen, everyone? This palladium will produce enough amount of hydrogen in the form of nascent hydrogen that will be sufficient to reduce aldehyde also. So this is known as Rosenmund reduction. Very important, Rosenmund reduction. I remember when I appeared for JEE examination, this was one of the questions asked during my time in 2009. Okay. And I remember very clearly my answer was correct. I always share this information with my students so that they also know the importance of this reaction. Okay. Then the next reaction here, let's come here. This is something which is pronounced as dibyl H. You have to read it as a dibyl H. Dibyl means diisobutyl aluminium. Diisobutyl aluminium with hydrogen. So isobutyl group is what? How does isobutyl group looks like? There will be a CH3 connected to another CH3, and that has to be connected with how many carbons? 1, 2, 3, 4. This is connected with aluminium. There is another isobutyl group present, which is also, this is now diisobutyl aluminium with hydride. There is a hydride present. This guy is a source of, this is dibyl H. This is a source of hydride. It's a reducing agent. It's a nice reducing agent. Source of hydrogens are reducing agents. This aluminium hydrogen bond is labile. It breaks and it goes in the form of hydride. Why hydride? Because the electronegativity of hydrogen is more than the electronegativity of aluminium. This is a polar bond. Okay. Now when you react it with RC triple bond N, what do we obtain? The hydride is going to attack on the delta positive center. This is delta negative center. Hydride attacks here. And this double bond moves to the nitrogen. As a result of this, you obtain RC double bond nitrogen with a negative charge, and hydrogen is hanging here. Now once you react it with water, what is this negative charge going to do? It will try to neutralize itself by taking up hydrogen positive from water. It will form imine. This is known as imine. Carbon double bond nitrogen bonds are imine functionality. Since water is taken in bulk, what will happen now? There is no positive charge, no negative charge, but there is delta positive and delta negative charge. And now water takes advantage of this positive charge and attacks here. This bond opens up to the nitrogen once again. You obtain RC single bond nitrogen with a negative charge, hydrogen, and this is hydrogen already. Water forms bond with carbon positive. This is oxygen with a positive charge. Nitrogen negative takes up the hydrogen from here in the form of hydrogen positive, and it becomes a neutral molecule. I'm rubbing off this part so that we can discuss more things. Right. From here, what did we obtain? R nitrogen neutral now. The hydrogen has moved from oxygen. Correct? And just now we discussed that carbon cannot tolerate two electronegative elements like both oxygen or one oxygen and one nitrogen atom. Now immediate loss of ammonia. Why sir ammonia? Why not water? Because the loss of water will immediately give you the same molecule that you had in the beginning. Also we know carbon double bond oxygen is much stronger than carbon double bond nitrogen. Why should we form weak bond? The molecule will try to form strong bonds. There will be loss of ammonia, and the compound obtained would be RC double bond oxygen and hydrogen. This is your aldehyde obtained. You started from nitrile or cyano compounds. So alkyl nitrile, RC triple bond N upon acidic hydrolysis. Can be forced to produce aldehydes. Clear everybody? Good job. Next reaction is again a dibyl H treatment. I have explained to you what does a dibyl H do. This will be kicking out chlorine and you can directly obtain aldehyde. Again there is dibyl H, hydride comes on this carbon, this kicks out this alkoxy group, again aldehyde is obtained. This combination produces again nascent hydrogen, which is responsible of reducing CH3C triple bond N. If you have CH3C triple bond N and SnCl to HCl combination. This is known as Stephen's reduction. Remember, very important. This is known as Stephen's reduction. Right, everybody? All the reaction on this chart clear? All the reactions on this chart clear, everybody? Shall we proceed? Great. Let's move to our second method of preparations of ketones. Aldehydes done. Let's discuss ketones now. So we'll start from the ketone functionality. What is ketone? You have a carbonyl containing compound, and both these other valences of carbons are now satisfied by alkyl or aryl groups. So to distinguish between these two R group, let's say one is R, the other one is R dash. This is a ketone ka general representation. Method number 1. You start from RR. There is aqueous KOH treatment. KOH will come in here, kick out halogen. Another KH will come and it will kick out halogen. So the compound obtained will have 2 OH instead of 2 halogen atom. Both these are electronegative elements. Carbon cannot tolerate that. Immediate loss of water will generate minus H2O will generate ketone. Clear? Next, dialkyl cadmium. These are dialkyl cadmium compound. These are organometallic compounds. A strong source of R minus. These are strong, very extreme, or you can say they are excellent source of R minus, alkyl minus. Now R minus comes in. What is it going to do? They will attack on this center. Chlorine will be kicked out and you will obtain this compound. That's your ketone. Again, you can start from an aldehyde, from an alcohol using PCC and PDC. There are already 2 groups present. So the final compound obtained would be a ketone. Understood? Just a ketone. Let's come to the left hand side panel of this molecule, of this slide. You have RMGX treatment with RC triple bond N. I am going to explain this. What is RMGX, guys? Everybody know this is Grignard reagent. Don't call it Grignard. It is Grignard. Plus R, let's say R dash C triple bond nitrogen. First step has to be done in dry conditions. Dry means no water allowed. If you have water, the reaction will be killed. Reaction won't work. This has a huge delta negative charge. Metal has huge delta positive charge. This negative charge attacks on the center, which has high delta positive charge due to this nitrogen. And now the bond breakage, bond formation will start occurring. R dash carbon double bond nitrogen. Pi bond is broken. Partial negative charge becomes absolute negative charge. Carbon and R, they have formed bond. Clear? The negative charge will be satisfied by Mg X and Mg carrying 1 positive charge. Very good. Now once the reaction is over, you will be adding water, that's H2O. So the compound formed would be NH. And we just have learned that imines are water sensitive. Imines are water sensitive. What happens to imine? What happens to imine? Let me write general equation. RC double bond NH. If you have hydrogen here, you treat it with water, just break this bond, just break this carbon-carbon double bond. Left hand side, you give oxygen, right hand side, you give hydrogen. So carbon will receive, carbon is going to receive, since it is losing 2 of its valency, so carbon gains 2 valency by the help of oxygen. Nitrogen has lost 2 of its valency, both these valencies will be completed by hydrogen. This is the result of hydrolysis. So once you have obtained this, will the reaction stop here? No. You will obtain R dash Cr double bond oxygen plus NH3. What is this compound, everybody? Now this is ketone, and this is what you intended to make. यही बनाना चाहते थे. This is what you were intended to make. Let's go back and discuss the next reaction. Suppose you take 2 of these carboxylic acids and treat it with manganese oxide. There will be exchange of R groups. There will be some sort of rearrangement and the compound obtained will be a ketone. So one of the R will come from one carboxylic acid, the R dash will come from another carboxylic acid. Now this compound is R dash C double bond OCl. R comes from Grignard reagent, attacks here. Chlorine is a leaving group, it leaves and forms a ketone. All the reactions covered from this page, everybody. All the reactions are done. Understood? Wherever you are thinking there is any issue, stop the video, pause the video, watch it once again, drop a comment. I will be there to help you. Next. Reductive ozonolysis or oxidative ozonolysis is one of the method to prepare aldehyde or ketones or acids also. Suppose you have a carbon-carbon double bond and both these valences are satisfied by some groups here. What groups? We don't know yet. Once you do the ozonolysis, you just need to break this carbon-carbon double bond. Since this carbon is lacking 2 valencies, this carbon is also lacking 2 valencies. You have to satisfy both of them by providing oxygen each. Depending upon the groups here, what are the groups present here and what are the groups present here, you may obtain an aldehyde or a ketone. And depending upon the reaction condition, if you use zinc or if you use dimethyl sulfide, then the product obtained will be always aldehyde or ketone. But suppose you do not use zinc or dimethyl sulfide, the aldehyde which was supposed to form will undergo further oxidation to generate acids. Hence I said this is a method, reductive ozonolysis is a method to produce aldehyde and ketone. Depending upon the groups here, what are the groups over here, R or hydrogen, what are the groups present on the carbon, or depending upon the reaction conditions, you should be able to oxidize the resultant aldehyde into. Remember, only aldehyde will be further oxidized to produce acids. And ketones cannot be further oxidized by ozone. Clear? Let's take an example. Then the things will be much more clearer. I have carbon-carbon double bond. This side, these are the groups, and on the left hand side, these are the groups attached. Once I react it with ozone, with zinc, what you need to do? Just break the carbon-carbon double bond and provide both these carbon oxygen atom. Now here also. So what's the nature of the left hand side compound? Is it an aldehyde or a ketone? That's an aldehyde. You should be able to identify what is an aldehyde, what's a ketone. You should be able to identify. And identification is not very difficult. It's not very difficult. If one of the valency across carbon double bond hydrogen, one of the valency is fulfilled by hydrogen and the other one is either by R or H, then it's for sure an aldehyde. If both the valencies are satisfied by carbon-based groups, then this will be for sure a ketone. Okay, very good. But if you treat it with ozone again, in the presence of H2O2, no zinc used. So what's going to happen? You were supposed to obtain an aldehyde plus a ketone. But what happened now? Ozone does not stop the reaction here. It will further oxidize just the aldehyde, not the ketone. Just the aldehyde. So the final compound obtained will be carboxylic acid, and for here it is acetic acid. Clear, everybody? What is oxidative, what is reductive ozonolysis? Understood? Let's proceed to the next part. Okay, now we have to discuss some particular reactions. How do we prepare benzaldehyde? Benzoic acid are the two very important molecules in this chapter. We need to know everything about it, left, right, up, down, everything about it. So I have benzaldehyde. What's the formula for benzaldehyde? Benzene having aldehyde group present on it. This is C double bond OH. This is called benzaldehyde. Okay. So there is a very famous name reaction, Gattermann-Koch aldehyde synthesis. There is another reaction, Gattermann aldehyde synthesis. Gattermann only by the name of Gattermann or by the name of Gattermann-Koch reaction. Remember, these set of reagents are different. When you bring in directly carbon monoxide and HCl in presence of anhydrous AlCl3, it is known as Gattermann-Koch reaction. But when you bring HCN and then treatment it with HCl or zinc or ZnCl2, this becomes Gattermann aldehyde synthesis. There is another reaction called Gattermann, where you study in haloarene chapter, Gattermann reaction, Sandmeyer reaction. So don't get confused with those reactions. This we have already discussed. This is known as Rosenmund reduction. Here we have H2 and PD with BaSO4 with a poison added quinoline. Then hydride will come from this source, nascent hydrogen comes in. That nascent hydrogen attacks here, chlorine is kicked out. Remember, if you do not use quinoline S, that's one of the poison here, then the compound obtained will no longer be benzaldehyde, it will be benzyl alcohol. Okay. You can also oxidize. This is known as benzylic oxygen, benzylic carbon. This is benzylic. So carbon, this is my benzylic carbon. Benzylic OH or allylic OH or allylic OH. These two can be oxidized to their respective aldehydes with the help of MnO2. Remember, specifically for two, one is benzylic, the second one is allylic. They will be specifically oxidized to benzaldehyde in the presence of MnO2. So MnO2 is a mild oxidizing agent known to oxidize this. Or you can use PCC. There is the next reagent. This I am going to explain to you. How do we actually do that reaction? So what is this reaction? I am going to write this ring which contained Br. I am going to write this as phi. Or chalo, let's take it as directly. Treatment with magnesium. What happens now? You will obtain a Grignard reagent. Grignard reagent is obtained. And the reaction says you are supposed to react it with HC double bond O, C2H5. Let's cross check whether this was the compound or not. Yes, C2H5. It is not C2H3, it is C2H5. Correct this mistake, C2H5. Okay, great. Now, once this Grignard reagent is ready, what do we know about this? Grignard reagent is C6H5. This is the formula for it. MgBr reacting with HC double bond O, C2H5. We know alkoxy are the good leaving group. This Grignard reagent attacks here and it kicks away the alkoxy part. The compound obtained is C6H5, C double bond OH. What is this? This is benzaldehyde. Very simple reaction, guys. I just suggest you to write down all these reactions with your hand on the papers just for once, if needed twice, and you will be master in organic chemistry. Let's come back to the other side of this reaction panel. This is known as Etard reaction. Very famous, high chances, very golden chance for this reaction to come in your board examination. What do we use? We use chromyl chloride. This is red color solution, chromyl chloride, CrO2Cl2. What is the oxidation state of chromium here in this compound? You need to answer in the comment box, right? Chromium ka oxidation state in the presence of acid. Then the compound obtained from toluene, very important reaction. Hydrocarbons can also be oxidized to benzaldehyde. This is your very well-known compound. This is known as aromatic diazonium chloride salt. Treatment with CH2 double bond and OH. This is known as oxime. This is oxime. Treated with oxime, the compound obtained is benzaldehyde. On this slide, this is very important. This is also very important reaction. This is also very important reaction. And of course, Rosenband reduction. These four are mandatory. Let's proceed to the next part. Now we have some properties to discuss of aldehyde. We have prepared aldehydes, we have prepared ketones, we have now seen how to prepare benzaldehyde. Let's discuss some of the reactions of aldehydes. What aldehyde or ketone can do for us. Suppose I start from an aldehyde or ketone. For distinction purpose, let me write hydrogen also here. If there is a hydrogen present, it will represent an aldehyde. If there is a R dash present, it will be a ketone. Very clear? Good. Now I am bringing water. So R, C double bond O, R is being attacked by water. So what is water going to do? It will break the pi bond. It will break the pi bond and it generates oxygen positive charge. This negatively charged oxygen immediately picks up this hydrogen positive and the compound obtained is R, OH, H. This is R. And there is OH. What is this compound? We know there are two OH groups present. Obviously, this is not a very stable situation. There will be loss of water. There will be loss of water to get back the ketone. So this reaction is very poor reaction. Suppose I change this nucleophile, this is called a nucleophile. I'll change the nucleophile water from water to alcohol. What's going to happen instead of getting OH here? You will obtain OR, and a carbon containing, and a carbon when has one OH group present. There are two carbon groups present here and one OR group present. This is known as hemiacetal or hemiketal. Hemi means half. If you start from a ketone, it will be known as hemiketal. If you start from an aldehyde, it will be named as hemiacetal. Hemiacetal or hemiketal. Hemiacetal or hemiketal, depending upon the starting material, if it is aldehyde or ketone. I don't want to stop the reaction here. I want to do another attack by the alcohol. So the carbon will have both OR groups present instead of OH and OR. Both of them are now OR. So this will be known as directly acetal or ketal. Don't say it is a full acetal or full ketal. It is just acetal or ketal. This reaction is a very important reaction. Reaction with sodium hydrogen sulfate. This is a salt, Na plus and HSO3 minus. So this attack of the nucleophile happens on the carbon here. This opens up the pi bond. The pi bond negative charge on the oxygen will be satisfied by. Let me explain this reaction. I have R, C double bond O. Very important reaction this is. Let's start with the ketone and reacted with NaHSO3, sodium hydrogen sulfate or sodium bisulfite. Na plus HSO3 minus. So this attacks on the center, this bond opens up and you obtain R, oxygen with a negative charge, R dash as it is, and there is SO3H. I want you to open this molecule structure so that you know where is this hydrogen present. Can I say that this H2SO, this NaHSO3 would have been prepared from H2SO3 and reaction with NaOH? NaOH, not NaH. NaH also will also work. So what's the structure of Na? What's the structure of H2SO3? This is the molecule. This is the molecule, right? So NaHSO3, this is the structure. Suppose, so NaH has reacted. With which hydrogen it is going to react? Is it going to react with this hydrogen? No. Is it going to react with this hydrogen? Yes. So the actual molecule structure is this. R, CO minus R dash, and the bond is with this hydrogen. I am sure now you have followed what is the structure of the molecule. Sir, this is an acid, hence it is reacting with NaOH. So there are two acidic protons are present, so it can react with 2 moles of NaOH. Yes, do you notice one of the OH has already reacted with the base, there is one OH still present in the compound obtained. Now this is an acidic site. This is an acidic site in the molecule, and this O minus is the basic site in the molecule. Basic site in the molecule. Now what is this basic site does? This will pick up the hydrogen plus from the intramolecular attack via intramolecular attack. This forms OH and that becomes dash oxygen, S double bond O, hydrogen, and O minus, which will be satisfied by the sodium cation of the molecule, O minus Na plus, which is written as RCOH, R dash, and SO3Na. This is the final compound obtained. I want you to understand this step very carefully. This is known as intramolecular proton transfer or intramolecular acid-base reaction. Intramolecular proton transfer or intramolecular acid-base reaction. Within the same molecular framework, there is a base, there is an acid also present. So they two react to form the compound. Salt is obtained. Understood, everybody? See this. This is the salt obtained. Oxygen is neutral. Oxygen is in the form of OH. This is your HCN reaction. H plus and Cn minus. Cn minus attacks on the center. This bond opens up and becomes OH. Hydrogen becomes this site OH. This is known as cyanohydrine. Cyano and hydrine because of OH. All the reactions clear on this page? Can we proceed? Yes, let's go. So there are some more reactions of, there are some properties of ketones. Let's start from the middle compound. This is the framework mentioned here. You can reduce this compound to 100% saturated alkane. This is an alkane, 100% saturated alkane. Saturated alkane. Saturated alkane. How do we do that? By the help of Clemmensen reduction. What do we use in Clemmensen reduction? We use zinc amalgam. Zinc amalgam. Zinc with mercury in the presence of acid. Hence, there is one very beautiful question people ask in board examination. Which method should be chosen to reduce a carbonyl compound? Which one? Should we use Clemmensen reduction method or Wolff-Kishner method? Sir, here also we are getting an alkane, 100% saturated alkane. Yes. So which one is a better method? Both of them are good. Which one is a better method? Depends upon the structure ka demand. If your structure has acid sensitive group, then you should go with this. Acid sensitive group. Then you have to go with this method, Wolff-Kishner reaction, because it is using basic medium. But if you are using a compound which has base sensitive groups, then what you are going to do? You will be using acid medium, because base will be having the base sensitive compounds will start reacting with the base, but they are okay with acid presence. So for acid sensitive group, let me write, for acid sensitive groups, which reaction is favorable? Which reaction is to be done? For acid sensitive, can we use Clemmensen reduction? No, we have to use Wolff-Kishner reduction, Wolff-Kishner reaction. And for base sensitive groups, can we use basic medium? No. What do we need to do then? We need to use Clemmensen reduction, CR, Clemmensen reduction. Very, very, very important, guys. Very important reaction these are. Let's come to the left hand side. So here you want to reduce it to an alcohol. Just react it with pressurized hydrogen in the reaction vessel. Approximately 1000 psi. That high pressure is required. Generally, you know, in your car tires, in your bike tires, we fill the pressure and measure its pressure inside. We fill the air and we measure its pressure with the unit of psi. Next time when you go to the petrol pump or any place where you are filling up your tire, bike tire or car tire, know the value. You always should check the value, how much psi you are filling in. Now nickel at 50 degrees Celsius is enough to reduce this compound. There is a lithium aluminum hydride, which is again hydride source. Remember, not hydrogen nascent, hydride source. Sodium borohydride is also hydride source, H minus source. So what are they going to do? They will attack here. What is this going to do? Again, it will attack here and the pi bond opens up. So you will obtain an alcohol. We have studied these reactions in alcohol phenol chapter also. You can do the oxidation of an alcohol to get the ketone. Clear? Very good. Suppose you want to use sodium metal in ethanol. This combination will generate hydrogen. This combination will again generate nascent hydrogen. But when this combination of reagent is used, it has got a name, Boulent blank reaction. Boulent blank reaction, very important. Please make a mark. Please make a mark. You put your star, moon, earth, Mercury, Mars, whatever you want to put it here. Put it here to make it as a important point. It is very important. BB reaction. Okay. These are again important reactions. Sir, every reaction is important this chapter. You are saying yes, they are. This chapter has the highest weightage in your organic chemistry. Entire chemistry rather. Entire chemistry, this has the highest weightage. Every year you will see 2 to 3 questions. So starting from an aldehyde, we can do Tollens reagent ka treatment. Tollens reagent is ammoniacal silver nitrate solution. So this is my aldehyde, which is oxidizable. This is oxidizable. You can oxidize this to an acid, its corresponding acid, and silver precipitates. Silver starts precipitating. This is known as silver mirror. If anybody asks you, is it a silver mirror test? Actually, it's a Tollens reagent test. Silver obtained as a result of this reaction, silver in the zero state, silver in metallic form. You can also do Fehling solution test, which has copper as one of the reagent and Rochelle salts, Rochelle salt, sodium potassium tartrate. Then the compound obtained again is acid, salt of it rather. And the compound which precipitates is cuprous oxide. It is cuprous oxide, and that's a brick red in color. They ask you in the examination why or what species which is brick red color that precipitates. It's cuprous oxide. Benedict solution also can be used. Again, brick red copper precipitates. You can use moist Ag2O, that also will oxidize, but this time remember you obtain an acid, not its salt. Also, silver will start precipitating. Silver mirror will obtain. You can also use NaOX. NaOX ka treatment can be done. This will again oxidize it to an acid, and NaCl will start precipitating depending upon the medium. This reaction is very important, known as haloform reaction. For haloform reaction, you need to have two methyl ketone. This is methyl ketone. This is methyl and ketone. This framework is essential for haloform reaction. Treating it with X2 in the presence of NaOH, you will obtain the sodium salt of this carboxylic acid with CHX3 produced. Now CHX3 can be CHCl3, it can be CHBr3, and it can be CHI3. This is going to be a fruity smell or vapors. It generates a vapor basically, and it generates yellow precipitate, yellow PPT. This generate bright yellow precipitate, orange. Generally, the colors of these are generally yellow and white, orange PPT. Orange or yellow. Sometimes this is orange or yellow, and sometimes this will appear as a yellow and orange, depending upon the concentration, depending upon the amount also. The reaction is very important. Which particular molecules will show this reaction? Only ketones. Which type of ketones? Methyl ketones. That means in the terminal chain, whatever R group is present this side, you must have the ended chain should be ended by CH3. This should be the end of the chain. Now question comes, which method, which practical organic chemistry, which practical method means reaction, Rx, can distinguish between two pentanone and 3 pentanone. 2 pentanone and 3 pentanone. The answer is haloform reaction. Why? Because a pentanone is having 2 pentanone is this formula, 3 pentanone is this formula, this chemical structure. Now this has the framework that we are looking for. This does not have. So this will give us positive haloform test depending upon the X2 that you choose to use, and this will give negative haloform test. Clear? Right? Clear everybody? Good. Let's move to some of the properties of benzaldehyde to be particular. In the basic medium, if you react it with HCN, what do you get here? There will be a nitrogen which generates. There should be CN here. This should be CN. Let's fix this. This is CN. Okay. Now this cyanide H plus and CN minus attacks on the center. Double bond opens up. You get OH, and this is CN. Now CN we have studied under the acid treatment. What happens to it? It forms an acid. I want to explain this reaction. Let's start with RC triple bond nitrogen. When you react it with H2O, what happens? Water lone pair starts attacking on this carbon atom. Pi bond opens up. You will obtain RCOH. Oxygen has a positive charge. This is the double bond nitrogen with a negative. Intramolecular proton transfer happens from here. Hydrogen loses its electron back to oxygen positive charge species. Now the compound obtained has NH and OH. Oxygen will start losing its electron to form a double bond. this pi bond starts moving back to nitrogen. Now, nitrogen, carbon, negative charge. There is double bond hydrogen with a positive charge. Again, there is a loss of hydrogen. Again, there is a loss of hydrogen. The compound obtained is amide now. Compound obtained is amide. I will be using this reaction once again in this chapter later today. That if you start from alkyl nitrile, upon water treatment, just one water molecule is used and you can obtain an amide. This is known as partial hydrolysis of nitrile. Partial hydrolysis. But I don't want to stop here. I want to do further attack of water, which happens here, and NH2 is kicked out. So R C double bond OH forms, plus there is NH2 negative forms. This NH2 negative attacks on this hydrogen to generate R C double bond O minus, plus there is NH3 produced. NH3 produced. Now there is enough water, this acid will also be neutralized because there is water present. This forms R C double bond OH. So full hydrolysis, this is the result of full hydrolysis. Full hydrolysis. And this is the result of, from here to here, this is the result of partial hydrolysis. Partial hydrolysis. Partial hydrolysis. I am sure it is clear. Right, everybody? Let's go back and see what was the reaction here. Do you see that you start from an acid, from an aldehyde, you made cyanohydrine. That cyano part is undergoing an oxidation to form an acid. Clear? Good. This reaction we have already seen, Na plus SO3 HSO3 minus. This SO3 will lose its hydrogen back to oxygen to form a salt. This is NH2NH2. There will be reaction between C double bond O. This also I would like to explain once. If you start with R C double bond O functionality and react it with NH2, anything that is attached here, let's say that is Z here, then there will be loss of water. Condensation reaction. This is known as condensation reaction. H2O is lost. Now compound generated is having a double bond nitrogen and Z. Z can be anything. Z can be just the hydrogen. Z can be NH2 also, right? Z can be NH2. Z can be OH. Z can be OH. Z can be OH. Now Z can be NH2. Z can be NH2 ring, phenylhydrazine. Z can be 2,4-dinitrophenylhydrazine. Here also nitro. And on the para position also nitro. There can be anything. There can be anything. Z can be NH2, NH, C double bond O, NH2. Z can be this also. This results into semicarbazone. So all of these reactions are resulting into the formation of carbon double bond nitrogen. This is what I just told you, phenylhydrazine. This molecule is coming from phenylhydrazine. NH2 is hydrazine connected with the phenyl. This becomes hydrazone. This compound is hydrazone. Phenylhydrazone, zone, Z-O-N-E. Now left hand side, you treat it with chlorine. In the presence of heating, there will be hydrogen substituted by chlorine. Treating it with KCN, we know K plus and Cn minus. Cyanide will come and replace this, and as a result of this you will obtain, there is a reaction called benzoin condensation. This is very important reaction, very important reaction. I want to explain that. So benzoin condensation is when C double bond OH is treated with KCN, that is cyanide minus. Cyanide is attacking here, this bond opens up. As a result of this, you obtain, I'm writing this ring as PH. PHC single bond, oxygen, hydrogen is already present, and that has a cyano CN attached. Now in the next step, this hydrogen is this cyano, due to this cyano, this hydrogen has a very high leaving capacity because the negative charge formed will be very much stable. So what happens over here, you get this compound. There is a benzene, there is another benzene, there is a benzaldehyde. In the presence of KCN, there will be a loss of, there is a carbon COH present. There is a COH present. So far we have this compound made. Now when this negative charge wants to come back, either this CN should get out or hydrogen should get out. Due to this reaction, this hydrogen tries to get out. And if hydrogen tries to get out, what do you obtain? You can say that there will be pH C double bond O CN, and that is not a good compound. This doesn't make much chemical sense. So what will be this compound eventually going to do? There will be pH, another molecule of benzaldehyde coming into the picture, another molecule comes in, and that these two molecules will start coupling with each other. These two will start coupling with each other, and as a result of this, that coupling, there will be benzoin condensation. The compound obtained will have C double bond O and CH with one of the OH compound contained. This is also known as, this compound is alpha hydroxy ketones. Alpha hydroxy ketone. So benzaldehyde, since it does not have any alpha hydrogen, can also undergo Cannizzaro reaction. There are no alpha hydrogen present. Cannizzaro reactions occur. Okay, Cannizzaro reactions occur here, and Cannizzaro reaction is a disproportionation reaction. The same molecule, disproportionation reaction. So the benzaldehyde will be oxidized to benzoic acid, and benzaldehyde will be also reduced to benzyl alcohol. This will be the Cannizzaro reaction and benzoin condensation. Since it's a condensation reaction, so one of the C double bond O becomes an alcohol, the other one remains C double bond O, and there is a condensation reaction happening between the two. Now once you treat it with nitric acid, this benzoin gets, this is the benzoin formation. This is C double bond O, C double bond O. So benzoin upon reaction with KOH will form benzoic acid rearrangement. Let's discuss that also. So we have pH, C double bond O, and pH. So what is the reagent here? KOH. So KOH comes and starts attacking here, K plus and OH minus. OH minus attacks here, this bond goes to the oxygen, and pH, C double bond O, carbon with an oxygen negative charge. This is a pH and OH. Oxygen wants to return its pi electron to form the pi bond. Then it says, no bhaiya, I have already formed 4 bonds, I cannot form 5 bonds. This pH is kicked to this carbon and it opens up the pi bond. Neighbors are anyways for help. Neighbors are required for help, and this oxygen is helping. Now this molecule becomes with both the pHs on the same carbon, both the phenyls on the same carbon. Now this negatively charged oxygen will pick up the hydrogen, again intramolecular proton transfer. Oxygen becomes OH, this is pH, this is C double bond OH. Now this molecule can be made neutral by the help of water treatment. When you add water, this becomes benzoic acid. So starting from benzoin, you can do benzoic acid treatment. Benzoic acid. This is the compound obtained. Clear everybody? Check. You can further make it neutral molecule. Moving forward. Yeah, some variations of benzaldehyde. You can treat, as I have discussed already, you can treat it with this H2 and oxygen molecule will be lost. You will form carbon double bond nitrogen. This is known as 2,4-DNP. 2,4, this molecule. I'm talking about this molecule, 2,4-DNP, dinitrophenylhydrazine. 2,4-DNP. This molecule will form semicarbazone. There is a hydrogen here. Now this molecule, as I said, this metal and HCl combination will generate a nascent oxygen that will be doing the reduction of benzaldehyde to form an alcohol. This is NaOH treatment, that is I was discussing, that's Cannizzaro reaction. Name is written over here also, Cannizzaro reaction. So one molecule undergoes oxidation to form an acid, the other molecule undergoes reduction to form an alcohol. This is simple. Again, condensation reaction to form Schiff base. Schiff was the name of a scientist. On the left hand side, there is reaction, very important, Perkin reaction, Perkin condensation. Perkin condensation happens between benzaldehyde and an acidic anhydride, an acid anhydride, in the presence of their own conjugate base. If you react benzaldehyde with acid anhydride, that's with activated there is a active methylene containing compounds, those compounds, the molecule written here, it is this is known as active methylene containing compound, will react with benzaldehyde. There are two hydrogen present here. I'll bring in a benzene ring. I'll bring in the benzene ring, which is connected to carbon. In benzaldehyde, there will be loss of hydrogen. There is a loss of water, loss of water molecule. So this water is lost and carbon-carbon double bond is formed. Check please, carbon-carbon double bond will form. This molecular framework is here and rest of the framework comes from this molecule. This is known as Nowengel reaction. What is the name of the reaction, guys? Nowengel reaction. This is your nitroaldol reaction. When you react benzaldehyde with CH3NH2, this CH3 will start reacting with KOH or NaOH used, that will form condensation reaction once again. This is CC double bond, carbon-carbon double bond formation. This is also carbon-carbon double bond formation, condensation reaction. Once again, carbon C double bond O, and here there are two hydrogen from the CH2 and both of them are condensed to each other. Clear, everybody? Next part. Now, what does how to prepare some more reactions of benzaldehyde? Tollens reagent, since it's an aldehyde, it will react with Tollens reagent to give you positive test. It will react with Schiff reagent also to give you pink color. Fehling solution also, it will give you no color, no reaction. Why? Fehling solutions are particularly for aliphatic aldehydes. They are for aliphatic aldehydes. But what is the nature of this aldehyde? It is aromatic aldehyde. Noted, everybody? Fehling solution test is just for aliphatic aldehyde, but this is aromatic aldehyde. PCl5 will convert both these valencies by chlorine. Oxygen treatment, aerial oxidation, will convert benzaldehyde into benzoic acid. This we have discussed already. Benzaldehyde upon treatment with Grignard reagent will generate an alcohol. This reduction also we have learned, this is alcohol obtained. All these reactions are fancy reactions, they are already discussed. If you want to treat it with chlorine in the presence of AlCl3, this is your Friedel-Crafts alkylation reaction. So the chlorination will occur on the meta position. Why meta position? Because HO group is minus M group. This group is minus M group, and minus M groups are meta directing. Again, nitration, meta position. Sulfonation, meta position. This is also the similar kind of reaction. When you start with benzaldehyde, one molecule offers hydrogen, the another molecule will offer hydrogen, and both of them will prepare a dye known as malachite green. Will form a compound known as malachite green. All the reactions clear from this page, everybody? Shall we proceed further? Lovely. Now comes the turn of carboxylic acids. How do we form carboxylic acids? So we can start this. We have discussed already full hydrolysis. K2Cr2O7 or KMNO4, they are strong oxidizing agents. OA, which will convert an alcohol to an aldehyde and further aldehyde to an acid. This is also very important reaction to know, that dilute HCl with dilute HNO2, they too will start making this NH2 into diazonium. Then that will be converted into its corresponding acid. Because you are treating it with water, in the presence of water. Very unstable. HNO2 is itself very unstable molecule. It's also known as HONO. Very unstable molecule. Okay. Then we have some more reactions here. This is NaOI. This we have discussed. That's for 2-methyl ketone. This reaction is for methyl ketone. You have to tell me in the chat box, in the comment box, methyl ketone. What signature reaction methyl ketones they will display? What kind of reaction they will display? What is this molecule? Iodoform. They display iodoform reaction. SOCl2 in diazomethane combination, you can again replace this chlorine by this OH. Hydrogen, this is ester. Ester upon acid treatment can also be hydrolyzed back to an acid. This is ester hydrolysis. Acid hydrolysis. Ester ka acid hydrolyzed. Ester hydrolysis. Ester hydrolysis. Ester hydrolysis. We are going to see this reaction once again. Ester hydrolysis. Carbon-carbon double bond upon exposure to carbon monoxide in water will generate an acid. This is your acid anhydride. Again, acid anhydride breaking can be done with the help of water. This part will receive hydrogen plus. This part will receive OH minus. So there are two acids, or two acids will be obtained. There are two carbon containing acids. There are two carbon containing acids obtained here. This is aqueous KOH treatment. When you have three of these chlorine present around it, around the carbon, there is 1, 2, 3 chlorine present around the carbon, reacted with OH minus 3 times. Then all these 3 will be replaced, right everybody? All these 3 will be replaced. All these 3 chlorines will be replaced. So you will have OH, again an OH, again an OH. We have learnt already that the 2 OH also are not very stable on one carbon atom. How can there will be 3 possible then? So immediate loss of water will generate C double bond oxygen and OH. Acid is obtained from here, loss of water molecule. Let's go back. All done. KMNO4 we have discussed. This is known as, last reaction is known as oxidation of ketones. This is Popoff's. This is going to follow Popoff's rule. What is Popoff's rule? Suppose you have 2 molecules, R, C double bond O, R. Treatment with KMNO4 will break this bond. Suppose there is R and R dash, and R group is longer than R dash. Then what's going to happen? R group is longer than R dash. So compound will be obtained as R dash C double bond O. This bond actually breaks in this fashion. This R will also be oxidized to acid. This will also be oxidized to acid. But what is Popoff's rules then? Oxidized to an acid, corresponding acid. Then what is Popoff's rule? Popoff's rule says that upon treatment of a ketone with KMNO4, the C double bond O group retains with a smaller R group. Now let's take an example. I have CH3, CH2, C double bond O, CH2, CH2, CH3. How many carbons here? Sir, 2 carbons. How many carbons here? Sir, 3 carbons. This is a smaller one. So when upon the treatment of KMNO4, which bond you are going to break? The left hand or the right hand one? The right hand side bond. This bond is going to break because the smaller group will be preferred with C double bond O. So according to oxidation process, you will make the acid of the left hand side compound, giving it OH, and the right hand side compound will also be made into its corresponding acid. CH3 as it is, CH2 as it is, and then carbon will be made to its acid. Understood? Understood everybody? This is known as Popoff's rule. Popoff's rule. Popoff's rule. Okay. Yeah. Now some more reactions of carboxylic acid. How do we know that there is an acidic hydrogen present? Treat any compound with metal, and if hydrogen gas is liberated, then that means it is an acidic compound. How do you know it's an acidic compound? Treat it with a base. Simple. How do you know it's an acidic compound? Treat it with a base. Everything is just acid base reaction. Again base. Again this is This is known as hydrazoic acid. And NH3 is ammonia, remember, and HN3 is hydrazoic acid. So it reacts to produce RNH2. It reacts to produce RNH2 because this will break down the molecule into nitrogen gas, CO2 gas, and RNH2. This is one of the beautiful method of preparing amines, primary amines. Last reaction here on this table is HVZ reaction. HVZ reaction is alpha substitution or alpha halogenation of carboxylic acid. What is this carbon over here? This carbon is known as alpha. Just next to C double bond OH, this carbon is known as alpha. Treatment with X2 in the presence of red phosphorus. In the presence of red phosphorus, what do you obtain? You can substitute this alpha hydrogen by halogen. This is known as HVZ reaction. HVZ reaction. Depending upon how many moles you have, if you have 1 mole, you will substitute 1 carbon. If you have 2 moles, you will substitute both the carbons. Clear? If you have 3 moles, you can substitute all the 3 hydrogens here. Then, how do we convert carboxylic acids into its derivative? Very first treatment with PCl5, it will be converted to acid chloride. Treatment with PCl5 also can do that treatment. SOCl2 also. Sir, we have studied these reactions in aldehyde kit in alcohol phenol chapter also. Yes. Similar reactions. Similar. Ditto. Same reaction. Out of all the 3, this is the best method because the products obtained are the gaseous species. They will immediately escape the reaction vessel and the compound left over in your reaction vessel is the final compound, pure compound. You need not to do any further treatment of the purification. Now we have some more reactions of benzoic acid. How do we get that? Starting from this reaction, can you name this reaction in the comment box? What is the name of this reaction? What is the name of this reaction? Or at least name what will be the name of this reaction. Starting from toluene to benzaldehyde. Toluene to benzaldehyde. What is the name of that reaction? I am looking for. From here to here, what is the name of the reaction? Okay, and then toluene can be oxidized to benzoic acid upon treatment with KMnO4 and OH in a basic medium. This also we know pH MgBr upon treatment with CO2 will form this molecule. Let's understand how does this happen. So pH MgBr upon treatment with C double bond O, this is the negative charge here and it attacks on the carbon. The pi bond opens up. The reaction generates pH C with oxygen minus C double bond O. Do you see that the carboxylic acid generation has happened already? Or the benzoic acid generation has happened already? Now treat it with water. Water will neutralize the molecule to form C double bond O OH. That's your benzoic acid. Very simple reaction. Come back. Okay, good. We can do the removal of this OH group present on the ring with the help of zinc dust. This we have discussed now multiple times today. Nitrile ka oxidation, full hydrolysis, not oxidation, full hydrolysis. Yes, it is an oxidation of course, but the name is a technical name is full hydrolysis. This KMnO4OH treatment will also be just kicking away this halogen and putting up the OH here, and then finally you can do the oxidation. This reaction is also the generation of, upon the reaction of this molecule, AlCl3 is going to produce an electrophile, and the compound can be, electrophile will be sticking up to the benzene here. What is this C double bond O Cl2 molecule? You have to write the name of this molecule in the comment box. So what is the name of this molecule? COCl2. Acid chlorides are also water sensitive. The water is going to attack on the center. Cl will be kicked out and product obtained is carboxylic acid. Ester again, ester will also be kicked away. This alkoxy will be kicked away. Acids are obtained. This is again RC triple bond, RCX, RC3X. They were treated with 3 times OH minus to obtain RC double bond O OH. That's what we are doing here again. Most of the reactions are common. Most of the reactions are repeated. Just their faces are changed. Logic is the same. Last one, if you want to remove this SO3 Na group present on the medium, on the benzene ring, and substitute it with a carboxylic group, just fuse both the compounds with each other and you will just get a replacement of or exchange or substitution of sulfonic group by carboxylate. Okay, that was another reaction showcased by benzoic acids. Now this benzoic acid can also be treated with a combination of this NaOH or NaHCO3 or a simple base, acid-base reaction, pure acid-base reaction. Treatment with calcium hydroxide. Calcium hydroxide is a solid. Calcium hydroxide and they react together to obtain double this calcium ka salt is obtained, and then upon heating it, this is known as dry distillation, you will get that ketone as the product. You will obtain ketone as the product depending upon what was the starting material. Starting material here had pH as the R group, so that pH comes across carbon double bond oxygen. Treatment with ammonia, we have learned that we can first obtain amide, then we can obtain nitrile. Since we can do the opposite reaction also, nitrile, water addition, amide, further water addition, carboxylic acid. Lithium aluminum hydride reduction, carboxylic acid can be reduced to alcohol, as alcohols can be oxidized to aldehyde and then finally to acids. So acid can be reduced to aldehyde, can be further reduced to an alcohol. This is known as Schmidt reaction. What is Schmidt reaction? The reaction of carboxylic acid with hydrazoic acid will replace C double bond OH, and put down NH2 there. This is the similar reaction. This is the same reaction that we had here also. Yeah, this reaction. This reaction is the same. See this here. Reaction with HN3. This is hydrazoic acid. Acid with hydrazoic acid. You can obtain primary amines. Schmidt reaction. Schmidt reaction. The name of the reaction is Schmidt reaction. Okay. Acids and alcohol, you know very well, they can be mixed together, they can be reacted together to produce esters, fruity smelling compounds. Esters, fruity smelling compounds. We also see that the PCl5, PCl3 or SOCl2, they can replace this OH to have a Cl on this position. P2O5 is a dehydrating agent. Soda lime is CO2 remover. So CO2 remover will give you the compound, just the benzene, and P2O5 will bring in the two carboxylic acids together. Water elimination will produce acid anhydride. This is acid anhydride. So that becomes one of the method of producing acid anhydrides. Make sense, everybody? All good. I know these are too many reactions, but they are what to do. They are the reactions included in NCERT also in hidden format, somewhere here and there, here and there, here and there. So all these reactions you are supposed to know, so that in examination, none of these reactions are new to you. Okay. Now let's prepare some acyl chloride. We are just going forward towards the completion of the session. Don't worry. So RC double bond OCl, PCl3, PCl5, SOCl2. We have just seen all these reactions. They can be converted to their alkyl halides. Now let's discuss some of the properties of acid halides. Acid halides can be treated. This acid chloride in general can be reacted with water. Water comes and attack. And Cl goes away. You will obtain an acid. In the reaction of acyl chloride with an alcohol, instead of water, alcohol attacks. Cl again goes out. You will obtain an ester. Acid and alkyl halide, they will react together to produce acid anhydride. Amine and RCOCl will react together to form amide. This is known as a dialkyl cuprate lithium. Dialkyl lithium cuprate. So this will form a copper. This will form a ketone compound, RR compound. Grignard reagent will again form ketone compound. So these are the few reactions of RC double bond OCl. Again, you can react with organometallic compound OMC. Organometallic compound R source. It is R minus source. R minus comes and attack on carbonyl carbon. Cl gets away. This is your Rosenman reduction. We have discussed this many times today. Lindlar catalyst reduction of RC double bond OCl to RC double bond OH. This is reduction again. You get hydrogen in the place of chlorine. This is your benzene. This is your benzene. ARH means benzene. Then reacting in the presence of AlCl3. What you can do? This group will start replacing chlorine. You will get Friedel-Crafts acylation reaction. How is this compound? How is this reaction happening? Because AlCl3 and RCOCl will generate together an electrophile which is known as carbonium. The RC double bond O acylium ion. This is acylium ion. Acylium ion gets substituted on or gets electrophilic substitution reaction will be Friedel-Crafts acylation. Reduction again, lithium aluminum hydride, sodium borohydride will produce an alcohol. Most of the reactions are repeated. So I have tried my best to include every possible reaction at wherever they suit. Okay, at whatever place they suit. Now, acid halide is done. We have discussed aldehyde, we have discussed ketones, we have discussed acyl halide, we have discussed so many compounds of carbonyl containing compounds. So now few questions about esters. Now esters, we have discussed acid and alcohol treatment together will form ester. This is important reactions to know. This is the important reaction to know. Thorium oxide is a dehydrating agent since it works at a high temperature. So this is vapor phase esterification. Alcohol and acid, they too react together to form an ester. Also here, we know silver is present. This will be minus charge. There will be a positive charge here. That positive negative charge will start attacking. Will start attacking on this compound, and iodine goes away. Silver iodide will start precipitating, and the compound formed will be an ester. Correct? Again, this is your compound. You can take either directly as an alcohol or its salt. The negative charged partner will attack on the center and it will kick away this. This is also known as trans esterification. This is also known as trans esterification. You start from an ester and you can kick away one of the alkoxy group and bring in new alkoxy group. This reaction is known as Bayer's-Villiger oxidation. Bayer's-Villiger oxidation, BVO reaction. Very important. Very, very important. What do? We just oxidize an ketone into an ester. What's the difference in this compound? What is the difference in this compound? Right in this bond, we have inserted an extra oxygen. Which part accepts the oxygen? The part which is having less electron density will be having oxygen next to it. So this is an oxidation of a ketone to its ester analog. This is known as BV oxidation, Bayer's-Villiger oxidation. So esters, we discussed that it is acid sensitive. It will hydrolyze back to its acid and alcohol. They are also in the treatment. When you treat it with water and OH medium, this is a sponification process. I am sure you must have studied this in your childhood classes also, in your 9th, 10th classes also. That's something called sponification. Sponification means this ester can be treated with base in the presence of water to obtain acid and alcohol. Then you can react it with RMGX. RMGX is going to attack here and alkoxy leaves because of its good leaving nature. Compound obtained is a ketone again. Finally, lithium aluminum hydride can also come with hydride and kick away OR. Logic is the same, guys. In all these reactions, logic is the same. OR leaves, hydrogen comes. R comes, OR leaves. OH comes, OR leaves. OH comes, OR leave, because those are better leaving groups. Alcohol is obtained as a result of reduction. When you react an ester with sodium and C2H5, this is, remember, BB reaction we discussed. So this is going to reduce it. And we have seen already lithium aluminum hydride and sodium borohydride also, they reduce it to an alcohol. So same treatment is also going to be seen by BB reaction. Now bringing in R to NH, what is it going to do? It will start getting, it will start to attack on the carbonyl carbon. It will start attacking on the carbonyl carbon. RO leaks, RO leaves. See this? RO has left. On this side, PCl5 and ROH treatment, PCl5 will start to, Cl will come, OR group leaves. See, in all these reactions, the idea is the same. OR has to eventually leaves. Alcohol comes, OR will attack. Which OR is attacking? That depends upon which one has a better leaving tendency and the one has a better nucleophilicity. We are supposing that this R has a better attacking tendency, hence it could replace OR. At the place of OR, now you have OR dash. This is again known as trans esterification. Trans esterification. Trans esterification. Claisen condensation. Claisen condensation is the reaction of an ester. These esters can be treated with, their sodium salt of this alkoxy part. Then you generate trans esterification. What do you have here? What did you have here? You have OC2H5. Again, you have OC2H5 to prevent any mixing of the compound. But you have substituted this part. You have clubbed with this part. This trans esterification will be on the top. This is known as Claisen condensation. So trans esterification is this. So we have used the same base so that there is no exchange of the alkoxy part. But now on this carbon, which was earlier only this part, we had only this part. On this alpha center, we have substituted this compound. All right. This is known as Claisen condensation. Finally, something about amide. Amides were obtained upon the reaction of acid with NH3. So this is a salt, acid and base reaction, salt production. Heating it will produce RC double bond O NH2. That's your amide. That's your amide. Amide is obtained. Okay. You can also react it with another kind of base. Amide is obtained. Another base, amide is obtained. Base, amide is obtained. Base. Now base is reacting with ArCOCl. Every time you can obtain amides. Every time you can obtain amides. Now amides can be reacted with water. Water will attack over here and NH2 has to leave. That's a better leaving group. NH2 is a better leaving group. Water can also come and attack here in the presence of OH minus. This forms a salt. This will form a salt. This reaction is known as Hofmann-bromamide degradation. Hofmann-bromamide degradation reaction. Bromamide degradation reaction. Bromamide degradation reaction. Why is it called a degradation reaction? Because you are degrading the molecule. You are degrading the molecule. Let me write it on the top somewhere here. Hofmann bromamide degradation reaction. Hofmann bromamide degradation reaction. Why degradation? Because amide seems to be degrading. Is there any C double bond O present here in the molecule? No. So amides are converted to amines. Amides are converted to amines. So the board examination people, they will trick you by asking what is the side product obtained, what happens to the sodium salt taken. NaOH has now been converted to Na2CO3 and NaX. Finally, acid anhydride. Take two molecules together, heat it in the presence of water eliminating groups or water eliminating compounds. Those are known as dehydrating compounds. Water eliminates. Again, you can use it in between acid chloride and acids. Acid HCl will start linking up. So HCl will be now neutralized by a base used. That's pyridine. Pyridine and HCl, they have very good friendship. Okay. Now acetamides, these are anhydrides, can also react with ammonia or they can react with RNH2 type compounds. What is this going to do? They will react on this carbon, the whole group will leave, you will obtain amide. Alcohol will also do the same treatment here, this will leave. Water will also do the same treatment, this will leave. So what have you learned, guys? You have, if you have RC double bond O in this chapter and there is a leaving group present, you can bring any compound here and it has to leave. Leaving group has to leave. Okay. Finally, some more reactions. We have acid anhydride which can be treated with PCl5. Again, Cl will come here. Cl minus attacks here. This whole group leaves. See, this compound is formed. Lithium aluminum hydride. Hydride comes. Hydride attacks here. This whole group leaves. Very good. Again, RMgX, R attacks here and this whole group leaves. Do you see that the logic everywhere? Everywhere the same logic happening here. The last reaction which is important is known as Perkin reaction. Perkin reaction is in between an aldehyde and acid anhydride and the compound obtained is alpha beta unsaturated acid. Alpha beta unsaturated acid. This is particularly cinnamic acid. Okay. This is the end for today's lecture, everybody. I hope all the reactions are clear to you. Let me quickly summarize what we have discussed and what is the theme of our discussion for today. We have RC double bond O. What was the theme, guys? We had to discuss reactions of aldehyde. We had to discuss reactions of ketone. We had to discuss reactions of acid anhydride. We had to discuss reactions of RC double bond O X, in particular Cl. We had to discuss reactions of RC double bond O OH. We had to discuss reactions of RC double bond O C double bond O R. So many reactions, so many molecules. We have covered 1, 2, 3, 4, 5, 6 molecules, 6 function groups in this today's lecture, everybody. So aldehydes can be oxidized, can be reduced, They can be oxidized, can be reduced, they can be substituted also. You can substitute them also. Here also the same you can do. You can oxidize, you can reduce, you can substitute also. Here in all of these there is one thing which is common. One thing which is common, if your alkyl group or if your C double bond, this is Lg here. Lg is a leaving group here. Suppose now you reacted with hydride source, it will attack, leaving group has to leave. You reacted with Grignard reagent, R attacks, this group leaves again. You reacted with Cl minus with the help of SOCl2 or PCl3 or PCl5, this leaving group has to leave again. This way you can substitute, you can prepare many compounds because of this leaving group tendency. This is the leaving group tendency, this also having leaving group tendency. Oh, these are the repeated cases. These two are repeated cases. Don't mind. So aldehyde, ketone, ester, amide. Amide is listed. Amide. That's what I was thinking. Something is missing. Total, they had to be same. Total, they have to be 6. Amide it was. R, C, double bond O, NH2. The idea has to be understood, guys. Rest everything becomes so easy if you understand why a group is leaving, what thing comes and attack, what is the group coming and attacking, why the groups have a tendency to leave. All those logics, once you understand, then the entire chapter becomes simple. I suggest you people to watch this video one more time because the reactions are so many in this whole chapter. In this entire chapter, there are so many reactions. You please pay attention to all these reactions and try writing these reactions once and try to understand them. Don't memorize at all. That's all for today, guys. Thank you so much for attending the session. I will bring another summary series for you. Till then, stay safe. Goodbye.